Welcome back, viewers. Welcome to our series of chemistry videos. In this chemistry topic, we'll be looking at atoms and molecules. All right, atoms and molecules. You may be wondering, what are these things you are seeing here? What you are seeing here now are a series of phenomena exhibited by atoms. So, but I'll first of all explain what an atom is all about before I can now talk about what all these things are doing here. Now, the atoms we are first described. So, the first person to describe atom is the Greek philosopher. A Greek philosopher known as what? Democritus. Democritus. So if you get this in exam, who was the first to describe an atom? Your answer will be Democritus. He's a Greek philosopher. All right? But we know that in 1808, John Dalton officially described an atom, where he said that an atom is the smallest indivisible particle of an element which can take part in a chemical reaction. All what he said, that first statement he made, would have been correct if he removed the word indivisible. All right? Because further study of atom shows us that atom is made up of these following particles. All right, I call it PEN. Pen. Atom, we have proton, electron, and neutrons. So these are particles of an atom. So it shows that these three things shows that an atom is actually divisible, not indivisible, as suggested by John Dalton in 1808. In this first video, I'm not going to focus on atomic theories but maybe in the next video I may talk about the atomic theories. But for this video to be brief and concise, because there are certain things I want, the aim, I have aim I want to achieve, my objective of creating this video. Now, moving on now, I will need to tell you about the proton, electron, and neutron. I may not write much. I will just be telling you. For the proton, we said that protons are positively charged. We said that the protons are what? Positively charged. Positively what? Charged. And then the electrons are what? Negatively charged. Negatively charged. While neutrons are what? Neutral. Meaning that they have no charge. So in terms of charge, yes, we can distinguish between these three particles. Protons are positively charged, electrons are negatively charged, while neutrons are what? Neutral, they have no charge. There are certain things we learned in secondary school on atoms I need to remind you of. So do well to pause the video and copy all these things now. There are certain things we talked about in secondary school. We said that number of protons equals number of electrons. When does this happen? When the atom is electrically neutral. When an atom is electrically neutral, we said that the number of protons equals the numbers of electrons. Now, there is equally a statement we made during the secondary school days. We said that when an atom gains an electron, it becomes what? It becomes negatively charged, right? And we equally said that when it loses electron, it becomes positively charged. Now, for that case now, if I give you something like this, F minus, and I give you F, here should be 19, and here should be 9. The atomic number of chlorine should be 9, while the mass number should be 19. And of course, here I'm showing you that it have a charge of what? -1. What if I'm asked to calculate from this information now? I am asked to calculate PEN. What does it mean? I am asked to calculate proton, electron, and neutron. What am I going to do? Of course, we said that atomic number, of course, when an element is written as X, like this, we say we can have something here A, and what we can have something here Z. We said that the Z here stands for what? Atomic what? Number. And then we equally say that something here, which is the A, stands for the what now? The mass number. Alright? Now, we define the atomic number as the numbers of protons in the nucleus of an atom. And we equally say that the mass number is the sum of the protons and the neutrons. So we are saying that A equals proton plus what now? Neutron. YZ equals just the numbers of protons. So if I'm to calculate PEN from this guy, from this atom now, of course, you already know what our proton should be. We said our proton will be what? Proton will be numbers of what? The atomic number. So what is the atomic number of this element now? We said that it is 9. Therefore, number of proton equals what in 9. Because we said that atomic number is what? Equals to the numbers of what? Protons. So proton is 9. What about electron, which I'll write like this now? Electron is E minus, showing the electron is negatively charged. The formula I will give you is proton minus charge. I've always said that students should always use this formula. Do not be tempted in exam condition to just look at it and just pick. Always use this formula to find the number of electron. Number of electron equals number of proton minus charge. So that if you do that now, number of electron equals, what's number of protons here we have 9 minus, what is the charge we have? -1. Of course, I'm putting the bracket there to distinguish the two signs. Now, if you open your bracket, E minus becomes, that's number of electrons equals 9 minus times minus gives you plus 1. What do we have as number of electrons? 10. So this is number of electrons, it becomes 10. But if you do this by mere looking at it, you may not see that electron equals 10. Some students may say 8. Right? So that is exactly what we're talking about. So you must use this formula. Electron equals proton minus what? Charge. Moving on beyond that, how then do we get the number of neutron? We said that number of neutron will be equals to mass number minus atomic number. So I may even say A minus Z. So if I do it that way, it becomes A minus Z. What is here minus what is here? What is here minus what is here? That means 19 minus what now? 9. So neutron becomes 19 minus 9, which will give us neutron to be what now? 10. So to calculate PEN for this particular atom, the answer becomes 9, 10, 10. That is our answer. Now I'm going to drop one now. You are going to solve it and you are going to drop your answer in the comment section. Make sure you like this video and make sure you share this video. First of all, like the video. Then solve the one I'm going to give you now. Drop your answer in the comment section. So this is what I want to give you now. All right. Look up here. Everybody will solve it and drop the answer in the comment section. Mg2 plus. Of course, calculate PEN. I'm not giving you anything here and here, because in this case, I'm assuming you already know the mass number of magnesium and the atomic number of what? Magnesium. So solve this now. Find PEN for this atom now. Drop your answer in the comment section. So with that, let's continue. Now back to what we have here. Back to what we originally have on the board. Please pause the video and copy out this solution, because I want to rub it off now. Like I said, there are some phenomena. When I'm done with this, that will be all for this video. So in the next video, I will continue from here. Now there are some phenomena. So I will assume you have copied this one out. So I will remove them from this place. All right. All right. There are some phenomena exhibited by atoms. Let's look at the first one here. All right. This and this, and then this and this. There is one phenomenon I want to talk about. We usually call it isotopy. Isotopy. My boss, who I learned a lot from him. He usually writes it as isotope. Then make this P capital, isotopy. That tells us that this will easily tell students that isotopy have same proton. So isotopes rather, because isotopes exhibit phenomenon called what? Isotopy. All right. So isotopes have same protons. So you can write it like this to easily remember. Like I said, I'm copying this from my boss, who I learned from. Now, so isotopy is same protons. Now, what is isotopy? Even from secondary school days, we define isotopy as a phenomenon whereby atoms of the same element. Listen to that statement. Atoms of the same element have different mass number but have the same atomic number. So atomic number is the same, and that's what we said, they have same protons. Of course, atomic number, proton. Atomic number is the numbers of protons in the nucleus of an atom. So different mass numbers, same proton number. That's isotopy. Atoms or elements that exhibit this phenomenon are known as isotopes. Elements that exhibit isotopy are known as what? Isotopes. These are example. 12 cis carbon and 14 cis carbon are what? Isotopes. This phenomenon is known as what? Isotopy. The same thing goes to chlorine 35 and 17 and chlorine 37 and 17. What is, of course, in some texts you may see this as expressed as percentages. It then means that this type of chlorine is 35%, while that other one is 37%, like that. All right? But the atomic number remains the same. So these are isotopes. Now, under exam condition, you should not be tempted to pick something like this. Let's assume I have 35 17x and 37 17y as isotope. These two are not isotopes. Why? Even though they have different mass number and same atomic number. They have the same atomic number, yes. Different mass number, yes, which meets the demand of isotopy. But remember in definition that I said isotopy must be made of the same element. Of course, the elements are not the same. This is element X, while this is element Y. Therefore, these two are not isotopes. All right? So that is isotopy, and we are done with that. Do well to pause the video and copy out whatever you need. Now, there is second phenomenon. which atoms of element exhibit, and we call that one isobar. Isobar, B-A-R, isobar. Isobar, I usually say it is the opposite of isotopy. Isobars, opposite of isotopy. It then means that for isobars, they will have, instead of having different mass number now, they are having what now? Same mass number, but different what now? Atomic number. That's the opposite of isotopy. This type of phenomenon, whereby atoms of the same or different element, of course this is potassium and that one is calcium, have the same mass number but different atomic number. This phenomenon is called isobar. What about this one we are seeing here? Well, if you look at this one, so this is an example of isobar. There is this third one called, and from here I can see, we call it isotones. Once again, from my boss usually writes it as isotones. He writes it like this, and that tells you something when you write it this way. Isotones. N, same number of what? So isotones have what? Same neutron, the same number of neutron. So when you check isotones, they will have same neutron. All right, let's check. If you subtract 14 from 6, you have the same number. 15 minus 7, that gives you the same number. This will give you 88, right? Of course. And that gives you the same number of what now? Neutron. Remember we said just now that neutron is gotten by mass number minus atomic number. So neutron in this one, 14 minus 6 gives you 8. Of course, in this one, 15 minus 7 gives you same 8. So isotones have what? Same neutrons. Do well to recognize them whenever you see them. So we will say that this and this are what? Isotones, while this and this are what? Isobars. Of course, these two examples up there are what? Isotopes. Look at the next thing we have here. If you notice something here, I want everybody to check what is the relationship between these two things now. I want everybody to do it by themselves, but I will give you the name of the phenomenon. Tell me in the comment section what you discover that is unique to these two things now, or what is similar to these two atoms you are seeing here. Of course, this phenomenon, this last phenomenon you are seeing here as phenomenon number 4, we call it isoelectronic. Isoelectronic. So isoelectronic, of course, from the word iso, you should know what it means. So just drop your answer in the comment section what these two things have in common. That is much we can take in this video. I don't want the video to be very lengthy. Remember to like this video. Remember to subscribe. Subscribe to Affinity CHN because you have a lot to benefit. Subscribe to Affinity CHN. Tell your friends about this channel. Tell your friends about this channel. Do well to subscribe. Like this video. Give your answers in the comment section. This is what we can take in this video. Thanks and see you in our next video.